All right, you guys, this is BC Notes number 3. We're getting into a different type of parametric function. We call it vector functions, okay? And again, this can be found right after the parametrics section, the one that you just did previously, okay? And again, I encourage you guys to just have it out so that you don't have to rewrite everything. But there's also a benefit to also rewriting things from scratch so that it kind of sticks, okay? So go ahead and pause, press play whenever you're ready. Okay, so if you take a look, there are some, I guess, some glitches here, but I want to make sure that we fix it. Right above R of t here, that actually should be like an arrow. Okay, kind of like a half arrow. Okay, so go ahead and fix that real quick. There's one more right here. And I think there's one more right here. Am I missing any? Okay, so pretty much vector functions. If you guys have taken physics, you've seen vectors before. Don't worry if you haven't taken physics yet. But basically what you want to quickly take away is that vectors are basically, they have, Booth, they have both magnitude and direction. So pretty much they're pointing in a certain direction, but also there's a length to that direction. So vectors visually on a graph will look like arrows, okay? And there are certain lengths of the arrows which will be determined by its magnitude, okay? If you guys have ever watched Despicable Me, there's an evil character, I believe his name is Vector or something like that. And he claims that he has both magnitude and direction, something like that. Anyways, it's still some type of parametric equation because you have something that's dependent on time, okay? You have two variables that are dependent on time. So here, you notice that this vector right here is going upwards and to the right, but it also depends on what time it's going to be, all right? Okay, so some things to think about. There's a bunch of formulas, if you will, but I'm going to tell you guys right now, a lot of it is already intuitive, okay? Meaning you really don't need to memorize it, okay? Because, for instance, position is basically when you have your original function, okay? Which is basically here, just x of t and y of t, all right? So just remember position as your original function. But the only way that it's a little bit different is that when you write a vector, it's going to be written in vector notation. So it's going to be whatever your x is and whatever your y is. And then you're going to use these notations right here. They're called Chevron notations, like the gas station. If you ever take a look at the Chevron logo, they actually use chevrons. So those are indicators of vectors, okay? So you wouldn't write it like this because then that really just looks like a point. So just watch out for that there, okay? Okay, so if you have a vector, for instance, if you have a vector like that in purple, basically that vector is determined by how much you move horizontally, x of t, and how much you move vertically, y of t. And just like that last lesson, it creates a right triangle. So really to find the magnitude or the length of the vector, this is really you just figuring out the length of the third side here. And that's just the Pythagorean theorem, okay? And that pretty much comes out to this. Okay, the square root of your positions squared. Okay, all right. So remember that going from position to velocity, we just have to take the derivative. And that's why we have the derivative of x here and then the derivative of y. And this is what I mean by intuitive. It's something that makes very logical sense, so we don't have to remember it, okay? So yeah, velocity we know as the first derivative, okay? And you know, they write here dx dt. You could also write x prime of t and y prime of t. Lagrange, or I always forget the other guy, Leibniz notation. Either way is fine, okay? So they use those interchangeably. Just be careful of that, all right? Okay, so remember speed, we've seen before. The speed of the velocity vector, if you guys go back to parametrics, and I'll scroll real quick, speed of a particle is the square root of the derivative squared plus the derivative squared, respectively. Okay? So notice how that really is not any different. It's actually identical as parametric equations. Okay, so even if you're dealing with parametrics or specifically vectors, it's the same thing. Okay? Okay, so similar to velocity, how do you get to acceleration? You take the derivative one more time. So this right here is just the second derivative. And again, very intuitive. Okay? Okay. And again, you could also use this notation here for the second derivative and this notation here for the second derivative of y. Make sure that you guys are using those Chevron notations, okay, to indicate that it's a vector. So far, really, the only thing that might be possibly new is magnitude, but not really. Okay? Okay, so number 6 and 7. We revisit what we learned last year regarding displacement and distance. Okay? Do you guys remember what the difference is? So, just to illustrate, say you start right here. Okay? And say you decide to walk in this nature. And then you end right here. Okay? Your distance is pretty much everything in red, because that is the path that you took. That's how many steps you took. That is your total distance, okay? Displacement is really, it doesn't care what your path was, how far you are from where you started, that is your displacement. Make sure that you guys have a good understanding of that. Okay? And similar back to parametrics. I know I'm jumping back and forth here, but you guys should see. Notice the relationship between speed and arc length, or total distance. When I integrate speed, I get total distance. And if you guys remember speed, speed is velocity, but you don't care about the direction. Okay, so when you integrate speed, you get total distance. Write that down somewhere, okay? When you integrate speed, you get total distance. So I'll transfer that down here as well. Here's my point. Running out of space. So if you integrate speed, or the absolute value of v of t, which is speed, we get total distance. So if you take a look, here, I'm integrating this, right? Now, v sub 1 of t, this is new notation, okay? V represents the velocity, okay? Which is pretty much this up here. I'll put it in pink. Dx dt and dy dt. Okay? Because that's the velocity. So that's really this right here. So notice how we're integrating speed. So we should get total distance. Okay? This is how you guys make that connection. So if we integrate speed, we get total distance. This is written very differently, but that's still the same thing as dx dt and dy dt, okay? Now, what would happen if you were to just integrate v, which is velocity, right? When you integrate velocity, you're just going to get displacement because you do care about the direction, okay? When you don't care about the direction, you're talking about distance. When you do care about direction, you're talking about velocity and displacement here, okay? So if you take a look at displacement, we're just integrating x prime of t, and x prime of t is really just dx over dt. Okay, notice how there's like no absolute value bars there, right? So we know it's not going to be total distance. So just some subtle things to watch out for, all right? And that's it. Okay, speed is connected to total distance and velocity is connected to displacement. I don't know if you guys want to draw your arrows, but basically those are the connections there. So it looks like there's 7 different formulas, but really there's maybe 1 or 2 that you really have to remember. I would say remember magnitude and remember the difference between displacement and total distance, because everything else is very intuitive, okay? Okay, so here's one example for you guys, all right? After this, you guys are going to be working on your FRQs. Your FRQs are very calculator heavy. So what that tells you is most likely it's going to appear on your calculator portion of your exam, okay? Knowing that it's calculator, they're really not looking for a lot of work. They're looking for setup and answer, okay? Unless they ask for justification, and that's a different scenario. Okay, so have your calculators ready. Here we go. We have a particle that starts at point A on the positive x-axis and travels along the curve to B, to C, to D. So we're traveling in this direction here, just so you guys know. So we start at A and then we go to D, all right? So the coordinates of the particle's position, x of t and y of t, are differentiable functions where anytime they give you the equation, you write it down or you highlight it. Okay, so we have x prime of t here. And y prime of t is not explicitly given. Oh no. Okay, and then they tell you at t equals 9, the particle reaches its final position, D. So to reiterate, we start at t equals 0, and then we end at t equals 9. Okay? All right, so here we go. At point C, here's part A. At point C is dy dt positive. Okay? At point C is dy dt positive. Okay, so a little bit of a refresher, okay? When a derivative is positive, what are the implications, okay? When a derivative is positive, so for instance, if f prime is positive, what were the implications? Press play whenever you're ready, okay? When the derivative was positive, the function was increasing, okay? Similarly, when the derivative was negative, the function was decreasing. Okay? So here they're asking, is dy dt positive? So dy dt will only be positive only if y is increasing. If the derivative is positive, then y is increasing, right? Okay, so specifically at C, you guys, according to the y value at C, is this particle going upwards or downwards? And I say upwards and downwards because we're dealing with the y value here, okay? Okay, so at C, take a look at those blue arrows, right? Is the y value increasing or decreasing in value? Okay, since this particle is traveling downwards, okay, we can say dy dt is not positive since y is decreasing or going down. All right? And it's that simple. There are no trick questions to that, all right? So we got that one done. At point C, is dx dt positive? So if they're saying is dx dt positive, that's implying that x is increasing. Now, if you guys think about the x value, right, what two directions does x go in, right? So x can either go left or right. Now, if x is increasing, that implies that x is moving towards the right, okay? Now, take a look at point C. Is x moving left or right here? X is moving in a leftwards direction, okay? So we know that x is decreasing in value because when you move left on the graph, x gets smaller, right? So here, dx dt is not positive since, and think about how you would justify that. Dx dt is not positive since, I should say at x equals c, since x is decreasing or going left. Okay? Not that bad. All right? Okay, here's point B. The slope of the curve is undefined at point B. At what time is the particle at point B? So, a little revisit from the last lesson. So, we know slope as dy over dx, right? But since we're dealing with a type of parametric function, specifically a vector, remember that dy dx is the same thing as dy dt over dx dt. Okay, we have something over something. But the key word here is undefined. How do you make a fraction undefined? Press play when you're ready. How do you make a fraction undefined? What you do is you make sure that the denominator goes out to 0. So this right here implies that dx dt, the denominator, should equal 0. Okay? We want the denominator to equal 0 so that the slope could be undefined at point B. So we had to extract that information, okay? So now we know that the derivative of x has to come out to 0. So now it says at what time is the particle at point B? So notice how they give us the derivative of x right there in pink. Okay? So that's a very extensive equation, all right? You could solve it. Oh, it is calculator allowed, so that's fine. You can even do this by observation, but what you can do is you can graph that, okay? And you can calculate your zeros, all right? The way you would solve it just by observation, and I'll show you guys, you set the derivative equal to 0 because you want it to go out to 0 times the sine of pi over 2 radical t plus 1. Okay. So what you notice here, if you're very well versed in your unit circle, sine of pi over 2 comes out to some version of 1, okay? And this right here is going to give you some multiple of that, all right? So I wouldn't look at this because it's tough to kind of determine how that goes to 0, okay? But you notice here, with cosine, the cosine of what will give me 0? Think about your unit circle there. The cosine will come out to 0 at 2 locations on the unit circle. It's pi over 2. And I'll write it down. At pi over 2 and 3 pi over 2. So your job is, what can I make t so that it comes out to pi over 2? Right? So t would be 3 because 3 pi over 6 will reduce out to pi over 2. And again, don't worry if you don't see it, because we could always use our calculator to figure it out, okay? And to make a 3 pi over 2, t has to equal 9, okay? So 2 ways that you can do it: by observation, which, you know, all of you may not be able to see, and that's okay. And if you're not comfortable with that, you could just use a calculator, okay? I would just graph that very long function, and then I would find my zeros, okay? If you forgot how to do that, just let me know. Okay, so we know that dx dt will equal 0 at t equals 3 and t equals 9. Okay, but here's the thing. It says, at what time is the particle at point B? So what do you guys think happens at point B? Is that t equals 3 or t equals 9? Okay, at point B, that would be t equals 3, because they stated that at t equals 9, it reaches point D. Okay, so there you have it. T equals 3. Okay, and you guys will get practice at that. Don't feel like you guys will be experts after one problem. It's going to take a lot of exposure, okay? But, you know, when you look back at what you've learned, I'm going to tell you guys right now that parametric and vectors are the easy points that you want to get, okay? Because the calculator does all the work for you, all right? Okay, here we go. Part C, the line tangent to the curve at x of 8, y of 8 has the equation 5/9 x minus 2. So we have a tangent line, and there's the equation. Find the velocity vector and the speed of the particle at this point. Okay, so look back on that page of equations if you need to, but the velocity vector is basically the derivative of x and the derivative of y, specifically at t equals 8. So this is what we need to figure out, okay? And we also need to figure out the speed. And the speed, which is really the square root of each derivative squared. Okay, so pretty much we take these guys and we put them in here. So x prime of 8 and y prime of 8. All right. So we need to figure out what these values are, okay? X prime of 8 is easy because you have your derivative, okay? And, you know, if you program this into your calculator, we could call this y1. Wait, let me think about this real quick. If you guys are trying to compute. Yeah, okay. So it's kind of weird, you guys. You know, when you switch modes, I know in the last lesson we switched to parametrics. You're really only switching modes so that you can graph it. But when it comes to computation, you guys want to go back into the function mode, okay? So two ways you could do that. You could click on mode and then switch to function, or you could just reset your calculator, okay? So here's what I want you guys to do. And you might have to pause. I want you to program this equation as your y1, okay? So go to y equals and type that out there. Don't worry that this says t. You could put in x, and it'll still mean the same thing, okay? Okay, so press play whenever you're ready. So right now, this is going to be programmed as y1 of 8, okay? So in case you guys forgot how to do that, on your home screen, after you've programmed y1, you're going to go to alpha, trace, and then y1, so it'll spit out a y1, and you're just going to put parentheses, 8, and close. All right, and then you're going to write down the answer. My calculator is busted, so you guys are going to have to do that. Okay, so y prime of 8 is the task here, okay? So we can figure out, I'll highlight it. We can figure out what this value is and what this value is because they're the same thing. The obstacle here is how do you figure out what y prime of 8 is, okay? Especially when they tell you that y prime is not explicitly given. So what they want you to do is they want you to find it, okay? It's hidden somewhere and you just have to find it. So you could pause here and think about what you would do to find it, or we can just discuss it, okay? So what they do give us that we haven't used just yet is this right here, the equation of a tangent line. If you take a look at the equation of that tangent line, they give us the slope, which is 5/9. Okay? Let me erase that real quick. Now, slope, if you guys remember, slope, no matter what form you're in, is always dy over dx. And with vectors or parametrics, that's the same thing as dy dt over dx dt. Okay, so here's what you guys know. I know that my slope is 5/9, so I'm gonna go ahead and erase that. You guys could just rewrite it. That's 5/9. Okay. Now I also know my dx dt at time 8 because that's just whatever x prime of 8 is, which you guys can compute. That's your y sub 1 of 8 there. Okay. So what you can do here is to find out what dy dt is, you would just have to multiply whatever the value of x prime of 8 is times your 5/9. Okay? And that value is going in here. Okay? It's kind of tough because I don't have a calculator with me. All right? But some things that you want to point out. So you should have two different answers. You should have a velocity vector, and I should have written down the values. So you're going to have 3 decimal values in each of these coordinates. And your speed, I do have the answer. Your speed should come out to 5.148. So you know you did it right if you got that. Okay, if you didn't, just let me know and I'll sit with you and I'll take a look at your computations there, okay? All right, last one. How far apart are points A and D respectively of the particle? So let's go back to that picture. There's a lot going on here. So let me erase around you. Okay, so we know that we started at A, we went upwards to the left and then downwards to the left, and we ended over here at D. Okay, so we went up and then downwards over here. Okay, so they're asking you how far were you from part A to part D? How would you find out how far you are from point A to point D? Press play whenever you're ready. To find out how far you are from point A from point D, that's really just a horizontal distance, right? So remember, I should say horizontal displacement, okay? Now, how far you are from point A to point D, notice how they don't really care about the path that you took. They're just asking you, how far were you from where you started to where you ended? So that's code for horizontal displacement. And it's not vertical because there is no vertical movement, okay? So horizontal displacement, okay? So here, if you look back at your formulas if you need to, I know to get displacement, I have to integrate. Since it's a horizontal displacement, I have to integrate x prime of t. Okay? Now, I want to know how far it moved from time what to time what, right? Think about that there. What would your bounds be? Okay, so notice how you start at t equals 0 and then you ended on t equals 9. So this would be from 0 to 9. All right, so that's your setup. All right. On your calculator, remember that x prime of t is already programmed as y1. So just to revisit calculations, okay? To get to integral, we go to math 9. Okay? To type out this y1, again, it's alpha trace, and then you pick your y1. dt from 0 to 9. You can even do dx, it doesn't matter, but you should get this. So again, it's really setup and answer. So we set this one up, we get our answer. That's typically what you're going to see on your FRQs. Back here, setup, answer, answer. Okay? Very rarely will you show work. All right? That's a little bit of an introduction for you guys. I didn't go over everything, but this is enough for you guys to navigate through these FRQs, okay? So be very thorough with it. Don't rush through it because you want to do it right the first time, okay? I'm going to be there to support you guys. Go ahead and get started, and we'll go from there.